Hello, we're going to talk about, we're almost wrapping it up here. This is the Titan 9M. This is like the world of three-axis machining, full three-axis. In other words, it has curves right here. So now we're going to get into actually using the 3D area of 3D curves. So most of these will be ball end mill or flat end mill with curves on the corner. So it's really the full purpose of adaptive clearing is the three axis or 3D area. So we're machining like that pocket. We put little patches over the holes. The rest of this is really 2D contouring and 2D hole. But we're going to get on to operation 2, which is actually pretty simple. We're going to shut some of this stuff off. We're going to mill it back off to hold this size, which would be from here to here, and get that dimension correct. You can also do a backup dimension from here to here. So our Z0 is actually going to be in the center of the hole. So how do we get there? We either got to mill through, we have to put it in the first operation, we have to have correct jaws. So in this case, we got a set of jaws here, and you got to place your part in the contours. And right here, we got some information right here on setup. So G55 is going to be the center of the bore, but this is how to get to the center. We're going to go from the corner of the jaw and find the corner and shift over. Then we're going to set our Z0.500 from the pocket. So if I get into the pocket on Op2, let me pull up the jaw here. It's the soft jaw program. So we actually inserted it. It's upside down right now. Oops, right there. So that's operation 2 to make the jaws. You notice this step up here. So this is holding it on the contour, and the flattest part of this part is actually these outlying areas. So this area is actually not going to touch. You don't want to have interference between here and here. You want to pick one or the other surface, because if you're slightly out of tolerance, it'll still work. If it's fighting each other, then you're going to have a problem with holding the overall height dimension. So we're using the corner. This is the jaws we use to create it. We put it at the proper spacing. We put a spacer in here to machine it. And this will be operation 2 with the part. Right. So I'm going to close that up. We have 3 operations. I'm just going to regenerate right now. All right. So as it's laid out now, it thinks it's the whole thing's the material. I'm going to go back into the setup here, make sure that the setup is correct. And I'm starting to use new features on here. Like we can do, this is kind of like the cheating way of getting the stock correct. But if we did relative size from preceding setup and did continue rest machining, that works very well. Say yes. All right, I'm going to regenerate. Generate. All right. So we're getting some warnings here. Cannot verify material. Okay, let's go to the first operation. So it's kind of essential you do the first operation and simulate that one. All right, so I'm going to actually have to flip it upside down. That's without software. So that's our normal setup. XY in the corner with 3 little minor shifts. So I'm going to click on this one. And I'm also using the sync view command, so it's always aligned for me. All right. I'm just going to quickly do a simulate. Simulate. We got the comparison view on, so we're just going to start machining away. All right. Now this is the part where the ball mill comes in, where it's going to do the curve. So this is probably the most time-consuming part, because it's going to slowly, not too slowly, but start to work its way up and make those fine contours. Now you see them starting to get exposed. Almost there. So actually on these, our timeline is actually on the slow side. So we're probably also going to update our feeds and speeds in that area. All right, I'm just going to take it right to the finish line, let it calculate and catch up till this all turns green. So even on these 3-axis of 3D parts, the computer calculation time could take a little while. So it's actually still running right now. See the red ball right there? So it's still running. So if you want to know it's still calculating, that's one way of telling. It's got the little red ball there. All right. You pause for a second. Okay, I'm back. Actually, I had to play with my accuracy settings here. And it even says right here, choose a higher accuracy at the expense of slower generation time. And it was going pretty slow. So in the quest to get everything to turn green, sometimes it's probably not worth it. But when I had it at higher accuracy, I could get it to turn green. But it depends on the strength of your computer. So with that being said, world of 3D. So actually, in the meantime, I was actually able to improve my times here on the 3D sculpting. You have horizontal. There's actually 3 built in there. We're using the same mill to mill 3 surfaces. So I have in here a 3D finish setting for preset, and I increased the chip load by just 1/1000th. Now, these 3D finishes, oops, like engraving, are really how they look, how the visual looks, not really about chip load so much. So even at the machine, we'll increase the feed rate to see how visually it looks. And then later on, we can start putting in our updated numbers. So it's not really chip load in the sense of adaptive. That's really dependent on chip load. So I'm just doing this to improve my cycle time. So we had 9 minutes 46. So this increases the feed rate to about 73 inches a minute at 8100. So now it's 6 hours and 31 minutes. So and then I can change the spacing. That's also a visual look thing. So right now we have maximum step over and minimum step over. So I'm just going to double those numbers, 0.010 on maximum, and make the other one half of that. So that'll increase the space between steps. So this is going to be how it looks. The same thing here. I'm going to parallel. I already increased the feed rate there. I'm going to check those settings. I got maximum and minimum. So I'm going to go maximum of 0.012 and make the minimum is 0.0012. That'd be 10% of that. And also the step over direction in the, so we got step down and step over. That makes it just a little bit less refined, but that all work. And now we're down to 4 minutes. And on the scalloping, which is in the internal of the sculpted area, I already increased the feed rates, but on this one, I already did the 10,000 step over. So it's going to be a matter of how the finish looks at that point. But total machining time is 21:33. So we're always trying to look at those because these could be more time consuming. We're also using trace. We're using in the chamfering mode. So in here, and this is also going to become important in the Titan 10M. So trace, and with the chamfer turned on, 0, and make sure you get the left compensation on that.